Hello, welcome to apenasimagens.com channel. I'm Wagner Lungov, and in this video I'm going to show you this device over here. It's again a project using a microprocessor as an aid to analog photography, and I can tell you that this time what it does cannot be done otherwise. There are many printing processes that call for a UV light source. They use a contact printer like this. This is a vintage one. And I'm talking about Cyanotypes, Dyke Brown, Bichromate, salted paper, and there are also some premium ones like using platinum and palladium. Artificial lights for UV printing are normally the black light fluorescent tubes. There are also some fluorescent tubes called shortwave, which are more powerful. And going more specialized, you have the gas discharge lamps also producing UV. And more recently, we have also the option of LEDs like this one that produce UV light. And the problem for the amateur photographer is that the more energetic is the light beam, the more expensive will be the light sources and the apparatus he will need to power them. UV light goes up to 400 nanometers in wavelength. Beyond that, it's already the blue part of the visible spectrum. And the reason why these printing processes need UV is just because a photon in the UV part of the spectrum carries more energy than the ones corresponding to the visible part. But there is one UV light source that is powerful, is very rich in terms of wavelengths, and it's for free. And you know I'm talking about the sun. But the problem is how to control the amount of energy falling onto your print when you are using sunlight. In the case of artificial light, the problem of exposure can be represented in a graph like this. I'll put over here something related to the power of my UV light source, and over here the time of exposure. An artificial light normally has a constant power output, so I represent it by a flat line. And adjusting the exposure will be then a matter of just setting up the time of exposure. So let us say that the power is represented by P, and I have the time T over here. If by chance I have another light source with half of the power of the first one, I just need to double the time over here. I think it's easy to understand that in fact exposure is represented by the area beneath the graph power versus time. Here is the area of this rectangle. When we have the sun as a light source for UV light, things are a bit different because it's not constant. I cannot represent it by a flat line. It varies from one day to another, from one time of the day to another, and sometimes even during the same exposure it may be oscillating. So I'll set, let us say, a curve like this to represent the power output of or the UV light energy falling onto the print. In this case, we cannot set beforehand a total time for exposure. We need, in fact, to follow up and adding small slices here of area. And what we need to set beforehand is what's the area, what's the total exposure we want. And we need then to stop exposure when a certain area is achieved. And this is exactly the job done by this device over here. You set here in this keypad a certain amount of exposure you want. I didn't bother in finding the correct international system units for that. It's arbitrary. I made it in a way that if you set 30, it corresponds more or less to 1 minute under bright sun. Once you have set your exposure here, you have this is a UV sensor. It must be set side by side with your printing frame. And you start every 5 seconds communicating to the device what is the UV level. And like that, the time will start counting. Once you reach this 30 exposure level or 60, whatever, it will beep, and then you know it's time to stop exposure. So this is the setup I prepared for UV prints. I adapted this board here over a tripod so I can adjust the angle. That of course it's better when you have direct sunlight over your print. Over here I placed the sensor that of course must be in the same lighting conditions as the print. And I provided a shade here for the control box so I can easily read the display and keep the figures, so on and so forth. So let us see how it works. When you switch it on, the first thing you hear a countdown. That's the time the device needs to evaluate the amount of UV it's receiving in its sensor. It opens the screen. Here you have minutes and seconds. This exposure is where we set the amount of UV we want to give to a certain print. Down here I have a progress bar, and here it's a graphic representation of UV level. If the UV is very strong, this inner circle will fill the external one, and if the UV level is very weak, it will be just a dot. If I key, for instance, 20 and press star, it tells me the time needed for this 20 exposure. If I say, okay, let us do a test strip using this 20 as a level of exposure, then I press the pound sign. Now you see it started a countdown in time, and the progress bar started to move. From this moment on, when you press the pound sign, the device started to add up every 5 seconds or so the amount of UV it was collected by your print. And if something happens and the UV level for whatever reason drops, like I'm going now to cover the sensor with my hand, you see that the UV level dropped and the time exploded. Now it's 68 minutes. If I uncover it, it will quickly resume and come back to the level. Now I have again the level 66. That's what the atmosphere, the sun, the angle, the time of the day, the month of the year is giving me here. I am in the Capricorn tropic. So this is the normal exposure. You see that the progress bar is reaching the end. And when it's done, you hear a beep, a sound, and that means you can take your print and go for the dark room to process it. Maybe you're asking yourself what is exactly the advantage of this. If anyway you have to start guessing, and you have to start with a figure that you don't know what it is. Well, like I key here 20, but well, 20 what? But look, that's not the point. The point is that it's like a test strip. Once you have found the right figure for your print, you can repeat it. You can repeat it tomorrow, the next month, in the afternoon, during the day, whatever. The advantage of this is exactly giving something that is predictable, even with the unpredictable light of the sun. Well, this is what I wanted to show you in this video. It was more focused on the concept and how it works, what it does. But the complete instructions for building your own you will find in the website, and the link is in the video description. Over there you have the parts and how to assemble it, the software, how to load the software into the microprocessor, all the things you need. And one last word I'd like to comment is that I've been using it for 1 year now, and it really gives consistent results, provided you keep other variables of the printing processes constant, like the paper and the formulas and the way you apply the sensitive material. It really gives constant printing output. So Thank you for your attention and see you next time.